Good morning. Let me do this.
Good morning, sir.
Yes. Okay. So in our previous class, we explained that the data types, then their operations, and in the lab session, we little bit discuss about the typecasting. Okay. So typecasting, what do you mean by the typecasting? Is something like that. If we have one, say, so there is a typecasting. Okay. So there are different types of data like integer, then we have float, then character, then we have pointers, and pointers are integer pointer, then float pointer, character pointer, and we have a special void. Void pointers is also available. Pointers is also available. Okay. So now, if we look into the types in this way, then these are the types which are compatible. Compatible in the sense that you can sense an integer as a float as an integer, or integer as a float, or you can sense a character to be an integer. Yeah, because characters are encoded in an ASCII, then we can evaluate the ASCII value of that character. Okay. Similarly, pointers are not compatible with the integer. Pointers are basically the addresses where a variable stores. Clear? So this set of data types and this set of data types, they are sensed in a different way. Okay? And then if we have declared an integer, say I have declared an integer I, and in my program, somehow I have to convert this integer to a float. Say sometimes we values and then we divide by some by the number of incidents. Yeah, and then this average could be a float. Say A, V, E, average is a float. Yeah. So sometimes we have to convert this integer to a float, or maybe a float to an integer. So if we want to get the absolute value, we convert these things float to integers. Okay? Or it may require that a character may be converted to an integer. Okay? So C compiler, it defines a mechanism to convert this type. So we'll discuss the typecasting in the sense of that C allows to conversion of one type to another type. But keep in mind that this type should be a compatible. Like you cannot convert an integer pointers to an integer. Okay? So integer pointers have a different class of mechanisms or different class of interpretations, and data are different, having a different class of interpretations. Okay? So compatible types can be convertible. Means I can convert one integer to a float or float to an integer. Okay? And now there are compiler provides you two types of conversion. One is called the implicit type conversion, and another is called the explicit type conversion. The implicit type conversion performs these things when we are assigning a right hand side value to a left hand side. Like if I assign something A is a variable, and we are assigning these things to a B, which is another variable, and their types are different. Say this may be an integer, and this may be a float, or vice versa. Then this assignment operation itself, it does an inclusive conversion. Okay. And on the other hand, we sometimes require an explicit type conversion. Like I can write this way: float A to B. Clear? So,
sir, you are muted.
No, I am not muted. What is that? Am I
No,
not?
sir, you are not
No,
muted.
sir, you're not muted.
No, sir, you are audible.
You're audible.
Okay. So you are well listening to me. Is there any problem? Are you listening?
No, sir, we are listening, sir.
Okay. Okay.
Yes, sir, it is all good. Continue.
Okay. Fine. So so this conversion is sometimes it is required. It is performed implicit. So implicit operations or implicit conversion is only happens when we have a assignment operation. So there is a left hand side value. So this right hand side is a value. Yeah. And the left hand side is a variable. So I am assigning a value to a variable, then it requires a conversion of the type depending on the different declarations. Okay? On the other hand, this type of statement where we are explicitly converting the type A to a float, and then we are assigning the value to the B. Okay? So C programming will allow you to make a implicit type conversion. It also allows you to make a explicit type conversion. Okay. So we'll see different example where we have to do explicit type conversion and where the implicit type conversion occurs. Okay. The simple examples are something like this. So implicit conversion happens when we convert a character to an integer, or we convert an integer to a float. So these are all compatible type conversion. So we can do these things in an implicit way. Okay? But keep in mind that if we look into this statement, look into the number 2. So there is a declaration which says that there is a float variable d and equals to 5/2. Okay? So what is happening in this case? Say if we have a declaration as b, which is a float, let me write it. Float b, which is 5/2 or 5 divides by 2. Okay? So in this case, as you understand that there is an operator which is an assignment operator, and this operation will be performed after the division operation. So there is a 5, there is a 2. Okay? And they are integer, constant integer. And this is a float. Okay. So this operation will be performed first. So when this operation is executed, then this operation is executed on the integer data type. So we do not have a floating point result. We will have a result which is 2, instead of 2.5. It is basically a result is 2 because I am performing these operations on the integer data. Okay, and then there is a type conversion happens, and the 2 is assigned to a variable b, and then this 2 is converted to 2.000, and this is assigned to the variable b. Understand? So what we get is basically we are getting a value t that does not capture the decimal part. It only captures the integer part. Understand? Clear? Get it?
Yes, sir.
And then you look into the second scenario where we have a float d 5.0 divided by 2. So in this case, the operations are something like this. There is a d, then we have division, there is 5.0, then 2. So now it is a float. This is an integer. So this operation, this division operation is a floating point operation. Float. So it will capture 2.5, and then this float value will be assigned to the variable d. Understand? So writing d equals to 5.0 by 2 is good because I am able to make the floating point value at the left hand side of the variable. Okay, understand? So this is also an implicit conversion where integers is converted. So this integer 2 is converted to a float, and the operation is performed on the floating point data. Okay. So now consider the previous example where we have made d equals to 5 by 2. Yeah. Or let us take another example where we have three variables, say integer a1, sorry, integer a1, a2, and a3, and they are having their values. Now we compute the sum, which is an integer, and we can write a1, a2, a3, and we define a float, average, which is sum divides by 3. Okay. So what is the problem in this case? So this statement means if we, sorry, what happened? I'm not getting the, so this statement means at the right hand side, this is basically an integer operation. Understand? So even a plus b plus 3 is not divisible by 3. If a plus b plus 3 gets the value of 7, then the right hand side operation does not takes the value of 2 point something 3, something like that, or 2.1 in this one. Okay. So it will take the value as 2 because it will take the value as 2 because 7 by 3, if we consider these things in the integer domain, we will get only the value of 2. Clear? So there is no way to declare in this, like this statement, sum 0.0 by 3. Previously, I am able to declare 5.0 by 3. Clear? So in this case, C will not allow me to write a statement something like this, sum 0.0 divided by 3. So what we have to do, we have to make a explicit type conversion. So in this case, I have to convert the sum to a float. Float sum, and then I can divide by 3. Understand? So the meaning of these things is that now we can make the things in this way. There is a float. Sorry, there is a division operation which takes a 3. Then there is a type conversion, float, which takes sum, and this is average. Okay. So now the operation looks something like this. This is the highest precedence, so that will be executed first. So sum integer, it is converted to a float. Then there will be a division operation that will be executed. So we'll get some 2 point some xyz, and this xyz is now assigned to the average. Understand? Do you get this point?
Sir, if we consider denominator as a float point, so will you get?
We'll get, but sometimes we do not have this constant. Say if it is an n, then what we have to do? Understand? So we have only 3 numbers, so it is better I can use a 3.0.
So,
But
sir, implicit conversion is done only in values, and explicit is done on variables.
No, implicit is done only when we have an assignment. Clear? So assignment statement does the implicit conversion. But the thing is that this side will be evaluated depending on its characteristics. Understand? If this side is integer, they will be evaluated as an integer. Clear? But what we are doing here, we are evaluating the right hand side with a different characteristic. Sum is an integer, n is an integer, but I want to make this sum as a float. Understand? So there is an explicit requirement.
Okay,
I have
sir.
to explicitly convert this sum into a float. Understand? Yeah. So implicit is only applicable when we are assigning, when the right hand side will be goes to the left hand side. In that case, the implicit conversion is only applicable. But if the right hand side already evaluated to an integer, then that is not a requirement. Means I have to perform explicit conversion, and then compute, and then we assign. Understand? So the most suitable case is that if both of the things are variables, like sum is an variables, and instead of I declare an int n, which is 3. Understand? Then what we have to do? We cannot make anything like means if I use n, then I cannot make neither sum 0.0 neither n 0.0. Then I have to do some explicit conversion. Understand? Get it?
Okay, sir.
Okay, sir.
Oh. So there may be different cases where we require this. Means I have to I have both the variables. Means I have to read the numbers. I have to read the values. Understand? Means I have to read how many numbers. So n is that n says that how many numbers we are for which we are computing the average, and AB are the individual values. Okay. Get it? Understand?
Sir, one more thing can I ask?
Yeah. Yes.
Sir, here we don't know what is the value of sum. That is why we are explicitly converting into float, so that if it is sum is an integer and it divides by 3, so that doesn't give an integer value to the average.
That
is
doesn't
why
give
we
a
are
float.
explicitly converting.
Yes, yes. So explicit is that when we are computing, means as the right hand side we have to compute something that will be assigned to the left hand side. Okay. So if the computation requires an explicit conversion, then we have to do these things explicitly. Understand? But if this explicit requirement is not there, say I get already float, then I need not to do all these things. Understand? If I declare these things as a float, then I need not to do anything, because this integer value will be assigned to a float, so sum becomes a. There is no harm. Understand? But the scenario is something different. I have declared all these things as integer. Clear? And I need the left hand side. I need the right hand side computation to be a float. But all the values which are involved in the right hand side computations are integer. Understand? So in that case, I need somehow I need an explicit conversion. Get it? Understand?
Yes, sir.
Oh. So these are the conversions. We already discussed these things. Let us take an example how the things happens. Yes. Okay. So consider that. Yes, there are. In this example, I will discuss some more things. Say there are 3 variables. One is that integer. We have the value 321, and its binary representation is. I think this is wrong. Let me just check. Binary representation 101100. 1 minute, just take it. Is that 1? One 0 1 double 0. One 0 1 double 0 0 0 321. Okay, this is correct. So let integer there is a variable I which is having the 321 its value. Okay? And now I want to convert these things as a character. Okay? So if we represent 321 its binary, then it is more than 8 bits. Characters are 8 bits, but integers are more than 8 bits. So the binary representations of 321 look something like this. Okay? So there is a 1 which is exceeding the 8-bit representations. So what will be happening? So there will be a transition, because character C, the right hand side, the left hand side is a C, and C is character. So it is only having 8 bits. So this will be truncated. This will be this will be not considered, and the least significant 8-bit will be assigned to the variable C. Understand? Okay. So what is happening? So when we are converting a type, say upper type to a lower type, yeah, then there may be a truncations. There may be some loss of values because the size are different. Understand? Only the least significant part will be captured. The most significant parts are discarded. Okay.
Sir, Buzlam, not able to repeat code when.
Achha, let me do these things. Say this 321. So its binary value is 1, 1, 0, 1, 0, sorry, 1, 0, 1, 0, 0, 0, 0, 0, 1, something like this. Okay. Yes, understand. So I have an integer I, which 2, 3, 1. So this I may have 32 bits. Okay. So I can represent. So this is the 8 bits, and rest of these things goes beyond of 8 bits. Understand? So this data can be stored in a 32 bits representation because the information is 1, 0, 1, 0, 0, 0, 0. Okay. Now I have declared a character C, and I am assigning the value of 321 to a variable C. Understand? But C, it can only have 8 bits. This is 4 and this is 4. Understand? So how can I fit a 8-bit data into, sorry, how can I fit a 9-bit data? So this is 9-bit data into a 8-bit data. So there should be a loss of information. So which will be lost? So the least significant part will be captured. Understand? So it will be captured 1, 0, 0, 0. Sorry, 1, 0, 0 and 0, 0, 1, 0. Okay. And this one, which is beyond the 8-bit, that will be discarded. So this value will be assigned to the variable C. Understand?
Yes, sir.
Okay. So it says that when you have a conversion, there may be a case that you are losing. You may truncate the data. Clear? So because there is a size compatible, the size is different. So when we assign an integer to a character, then we basically may lose some values. Okay, understand? Get it? Similarly, if we assign the floating point to an integer, so this is also an implicit conversion. So floating point, we have the floating point, this one, okay, and we are assigning the floating point to an integer. Then what happens? The decimal points are discarded. Okay, so it will only consider the representation this one. So I will be only capturing 1601. The decimal point will be discarded. Okay. Get it?
Okay, sir.
And finally, if
No, sir, I don't get it.
means if we convert this floating point, what is the value of this floating point? It is 1601. Then the decimal value is 25, means 2 and 5. Okay. So if we assign these things as an integer, if we assign the floating point to an integer, then what will be the case? This decimal point, means 0.25, will be discarded. So I will capture the value of 1601. Okay.
Okay.
Yes. And finally, if a floating point data is assigned to a character, then what happens? Say this is the representation of the floating point data, means 1601. Clear? Understand? Okay. So the first thing is that the decimal part will be discarded. So after point, the information will be lost. And second part is that the least significant bit will be captured, means it will capture up to this part. Understand? So 0, 1, 0, followed by 001. That value will be assigned to the variable C. Understand? Get it?
Yes, sir.
So when the
So,
floating
but
point,
what will the character print if we assign float value to it?
yeah, that ASCII value will be printed. So this is the this is value, this is the code, but its ASCII character will be printed. I'll show you. Okay, I'll show what will it prints. But first we try to understand that it is fine. But when we have a float, okay, and we assign these things as a character, okay, then what happened? The first thing is that after the decimal point, means after this X, Y, Z, this decimal information is lost, then only the least significant 8 bits will be assigned to the variable C. Understand? Get it? Now if we run this program, then what it looks like, compile and run. So the value of this one means the value, this is the ASCII code. So this represents the capital. Understand? So I choose the this value because I can print the value, print the character. So this ASCII code 1010000001 represents the character capital. Understand? So the first thing is that I assign the integer to character. So only this code will be assigned to the character, and I am printing the character C by this print statement. So it displays A. Understand? Then the floating point data is converted into an integer. So this floating point data is converted to an integer. So the decimal point is discarded. So 0.25 is discarded. Then a floating point is converted to an character. So in this case, these decimal points are discarded, and the most upper significant part is also discarded. The rest 8 bits is captured, and this is basically the same. The two elements are basically same. So it also captures the capital. Understand? Is it clear?
Yes, sir.
Understand? So what we understand that implicit conversion is applicable. So I can convert these things implicitly. But when we convert upper caste data, means integer to float to integer or integer to character, so there may be a case where we are truncating the data. Only the least significant parts are captured. The most significant are discarded. Understand? Okay. And the opposite side is also something like this. So in this case, I am assigning a float to an integer. No, this okay, up to this point is done. Now what happens? I am assigning a character to an integer. So in this case, I declared C with a capital A. Is basically the previous one. This capital E is basically the ASCII code is capital A. Something looks like. Understand? So now I declare the C with a capital A, and now I implicitly converting the character to an integer and implicitly converting the character to a float. So in this case, there will be no truncation because I am casting the lower data to an upper part. So there will be no loss of information. So the first statement, what will print? It will print the ASCII value of the C, ASCII value of the character capital A, and that is 65. And the second part, what will print? It will print 65 point some 000. Okay. Understand?
Yes, sir.
Okay. Clear? So there are two conversions from the first thing says that you are converting upper type data to a lower, so there may be a loss of information. Whereas if we convert the lower to an upper, there is no loss of information, but only the representation changes. So C is representing the capital A, I is representing 65, F is representing 65.000. Understand? Get it? So,
Sir,
so
one more
this-
thing. Sir,
Yes.
if we assign F to A, character A, so that will also print 65.000 directly if we do.
means what we can do, F2,
Sir, in the 41th line, F equal to, we write capital F, which you have written in 38 line directly.
Okay.
That
Let me,
single
I
quote
have to
capital
check.
F.
Maybe I am not sure, or there may be an error. This one, no?
Yes, sir.
Let me check what happened. Yes, it does. It also prints the 60.5, 65.000. Okay.
Okay, sir.
So this is fine. Get and yes, finally, that what are the specifiers? So specifier is basically a format specifier. We call these things a format specifier. The thing is that, say, now think that I have some representations of data. Sorry. Say I have a variable I, okay, and I want to print these things. There will be a print f, and I have to print this value I in the console or in the terminal. Okay. So how can I print these things? So there are different way to print the things. Yeah. So there are specifier which tells the compiler that in which format you want to print the items. So there are different types of formats. We say percentage of t represents that I want to print these things as integer. Percentage of c tells I want to print these things as character. And this is the list. This is the which is very commonly used. This is the common uses of specifier. So specifier stands for percentage and a character. Clear? So percentage character or percentage C, we read these things as a specifier. Percentage D, we read these things as a specifier. It is there are some things like if we write an operator double equals to. Clear? So now we basically read these things as a single unit. Clear? Double equals to stands for equal to checking. Similarly, less than equals to, or sorry, less than equals to. So there are two characters we are using, but it stands for operator which says that it's less than equals to. Similarly, percentage D. These two characters implies that I want to print the I want to specify a printer, and this printer specify a printing options, and this printing option is basically integer. Okay, so whenever I read percentage followed by alphabet, we are basically read these things as a specifier. So percentage C stands for character, percentage D for integer, float, then this is octal value, then U stands for unsigned integer, X stands for hexadecimal, and there are different types of specifier we can use in our programming language. Okay. Sometimes what happens, say, if we want to display the items, say there are, you want to display list of price, say rice, price is 100, say potato, price is 50. Yeah. Then say what is sweet, rice is 5. Yeah. And this is one type of printing. Say rather I want to print rice which is 100, then potato which is 50, and then sweet which is 5. Okay. So basically what we are doing, we are reserving say 3 positions, and we are trying to fit our integer or the printable values within the 3 positions as a right alignment. So this is the left alignment. Basically by default all the data are printed as a left alignment, but you want to make these things as a right alignment. So you have to make some specifier which will instruct the compiler to print in a specific way. Understand? So in our programming language, we'll learn different types of specifiers. So I am not going to the details of these things. You can refer to some lecture, some helps or book, and you will get that there are different types of specifier, and every specifier having a meaning. So how do you identify a specifier? It is a percentage of some character, say minus I minus D minus 5D. It stands for, say, if I write minus 5D, then it stands for there will be five positions reserved, and the item will be printed as a right alignment. Understand? So all these item will be printed, say 1 0 0 0. So these are 5 positions, then 3 5 2, then 25. So all these things are right aligned. Understand? Get it?
Can you repeat this one? Minus sign.
So there are specifiers. Means if I write percentage of D, that means I want to print some value. Understand? So the value may be 10,000, something like this. Clear? Then for my second print, if the value is 200, then it looks something like this. Okay? So all these values are basically printed as a left aligned. Understand? Okay. So instead of if I write minus 5D, that means there will be 5 positions which will be reserved for the decimal integer values, and they will be printed as a right alignment. So if the value is 20, then there will be 2 blanks. So this will be blanks. And sorry, if the value is 200, then it appears something like this. Understood? Get it?
Yes, sir.
Okay. So there are different techniques you may learn. I am not going to the details, but just to mention that all these things comes into a format specifier. So you have to make a specifier. Understand? Okay. So the most commonly used is the character, decimal, floats, or in later case we'll understand the strings also. So these are the most commonly used specifier. Maybe octal, hexadecimal, etc. Okay. Okay. Get it? And let me show the example. Yes. Okay. So again, we take a specifier and the conversions. So we are trying to understand that whether implicit conversion works with the specifier or not. Okay. So in this case, I declared I as an integer, but I try to print this integer as a character. Understand? Okay. Do you get this point? So these two, when we talk about the specifier, then this character and integer, they are compatible, but floating points are not compatible with the character and integer. So if I assign this I as an integer, which is more than 8 bits, so this is more than 8 bits, then if we make these things as a character specifier, then there will be a conversion, implicit conversion. The most significant will be discarded, and the rest will be taken as the value, and its ASCII character will be printed. Understand? So 365, if we try to print these things as a character, it will, the most significant part will be discarded. So the value becomes 109, and now this 109 is the ASCII code of the character small n. Understand? So finally, I will be printed as a small n. Okay. Similarly, if we assign a character as a character 9, this character 9 is not the value of 9. This is basically, there is an ASCII code which represents the character 9. So if I try to print the character 9 as a decimal, then what will happen? Its ASCII value will be displayed. Understand? Okay. It does not display the 9. Rather, it will display the ASCII value of the 9. Understand? Get it?
Yes.
Okay. So let me run these things. So first it will print M, then it will print 57. This 57 stands for the ASCII value of the 9. Understand? And then what will happen if I try to make an integer to a float, then it does not work unless we make an explicit type conversion. Okay. So similarly, character cannot be specifier cannot format a character to a floating point value. So I have to make a explicit conversion. Understand? So what we find that this integer and character, they are compatible with respect to the specifier, but floating point is not compatible with the integer and character. So there is a requirement of explicit conversion. Okay. So if I just ignore these things, we will get a zero value. Say, run these things. So this should be the third print. The third print should be 65 or 65.000. Rather, it prints 0. Understand? The second is quite fine. The ASCII value is 55. It is converted to a float. Now it is printing 55.000. Understand? So the second statement, what it does, it takes the ASCII value of C, then it explicitly convert these things to a float, and now I am able to print the floating point specifier, floating point using this specifier. But the first case, it cannot. So it does not make a explicit conversion, and now it becomes all zeros. Understand? Okay. So keep in mind that when you are printing character or integer to a float or vice versa, then I have to do a explicit conversion. But character to integer or integer to character, it does not require an explicit conversion. It can perform by the compiler itself. Okay. Get it?
Yes, sir.
I think we have up to this point. So this is up to this point we'll cover for our CA1. So we start from how to write a program, then we move on up to data type and the type conversions and specifiers. Okay. Here you may get some more reference for the specifier. So you can search in the net and you will get there are different types of specifiers which has been designed by the C programming language. Understand? Okay.
Okay, sir.
So Jaydeep, before
Date of
conclusion,
CA1.
can I?
Huh?
Yes. So can we fix the date for this continuous assessment 1? I propose we may conduct the test on next Wednesday, that is 12th of January, during the class time. Is it
Yes,
okay?
sir.
Sir, on 12th we have
Because
a
we already
paper.
have one exam.
See, we have to arrange exam on our scheduled class day only. Huh? So only day we left